In marine surveys, the inline or main shooting direction is either in the direction of the steepest dip, normal to the structural trend of the faulting or the trap, or along the long axis of the prospect. Marine seismic data are recorded continuously as the vessel steams along at a constant pace, towing the receiver lines as a streamer cable. But the streamer does not always trail directly behind the boat. Ocean currents, tides, and winds often cause the streamer to drift off course. We call this cable drift streamer feathering. From magnetic compasses in the streamer, the seismic crew knows the amount of feathering. They can optimize the survey by seeing that the streamer stays directly behind the vessel or feathers onto the pre-plotted course of the survey line. Another common problem in marine work is that there will often be more than one seismic vessel working in an area. Simultaneous shooting can cause noise interference between vessels for distances up to 100 kilometers. Although some processing techniques can partially remove this noise, crews usually choose to time-share, shooting their lines in alternating time slots. Once a line has been shot, the vessel must continue in the same direction for about 2 streamer lengths, or 6 kilometers for a 3,000-meter streamer, before turning back onto the next line. When the vessel reaches the first shot point on the next line, the streamer will have straightened out. Typically, it takes an hour to shoot a line and another hour to move on to the next. In fact, marine acquisition crews can spend up to 75% of their sea time on turns, travel to survey locations, equipment calibration, and weather or equipment downtime. So we must be especially careful to get the most data we can from the time spent by minimizing the turning time. Some prospects may not require a rectangular grid. In these cases, we design unique stair-stepped patterns, covering only the area we need. If we need to contend with a major obstacle, such as an offshore platform, we might use a technique called undershooting. In this method, a recording vessel and a shooting vessel on opposite sides of the obstacle acquire data along a line halfway between the vessels. Because so much time and effort go into acquiring each marine seismic line, it makes sense to deploy the most efficient systems, including multiple streamers and sources. Today's surveys commonly use dual sources with 3 streamers producing 6 full-fold lines. Larger surveys may use 2 multi-streamer vessels, which yield 18 lines for each traverse.